Hello everyone, this is lesson 2-3, Understand Proportional Relationships and Equivalent Ratios. Our I can statement today says, I can test for equivalent ratios to decide whether quantities are in a proportional relationship. For this lesson, we are going to bypass the solve and discuss it and begin on page 98 with example 1. The essential question for this lesson asks, how are proportional quantities described by equivalent ratios? Let's take a look at example 1 to answer that question. In this example, we are going to recognize a proportional relationship. On Sarah's favorite mobile game, she is awarded game lives when she finds gold coins. How is the number of game lives awarded related to the number of gold coins found? Explain. So here you see 3 different pictures of her mobile game, and you can tell by the picture that she has hearts, which represent the game lives, and gold coins that tell how many she found to get those game lives that she was awarded. We are going to first write ratios that relate the gold coins found and the game lives awarded. In the first picture, she has 3 gold coins, and she was awarded 9 game lives. So the ratio is 3 gold coins to 9 game lives. In the second picture, she found 2 gold coins and was awarded 6 game lives. Therefore, the ratio is 2 coins makes 6 game lives. And in the third picture, she found 5 gold coins and was awarded 15 game lives. So that ratio is a ratio of 5 to 15. Now we're going to look at that same information in a table. And the ratio table helps us to determine whether the ratios are equivalent. So we have our ratio of 3 to 9, 2 to 6, and 5 to 15. And in each case, these ratios will simplify to the same ratio of 1 to 3. In other words, in the first ratio, you can divide both the top and the bottom numbers by 3 to get the ratio 1 to 3. In the second ratio, 2 to 6, you can divide both the top and the bottom numbers by 2 to get the ratio 1 to 3. And in the third ratio, you can divide both the top and the bottom numbers by 5 to get that equivalent ratio of 1 to 3. So we say that 2 quantities are in a proportional relationship if all of the ratios that relate the quantities are equivalent, which is a fancy way of saying, are those ratios equal? If they are, we have what we call a proportional relationship. So each ratio of coins to game lives is equivalent to the ratio 1 to 3. Therefore, we have a proportional relationship. If all ratios are equal, then we have that proportional relationship. But the converse of that is also true. And the converse of that says, if there is a proportional relationship, then all the ratios must be equal. Now let's take a look at the try it at the bottom of the page. Miles records the time it takes to download a variety of file types. How is the download time related to the file size? Explain. So let's take a look at the table. We have 3 different types of media. We have a document, a song, and a video. And in each case, we are given a file size in megabytes and a download time in seconds. And our ratio is the download time compared to the file size. So let's complete each of the ratios here in the table. For the document, it tells us that the download time is 25 seconds. And we are going to compare that to the file size, which is 1 and 25 hundredths. And that is, again, in megabytes. If I divide those 2 numbers, then I get 20. For the second type of media, we have a song. The file size is 3 6/10 megabytes, and the download time is 72 seconds. So the ratio is going to compare the download time, 72, to the file size, which is 3 6/10 megabytes. Again, if you divide those two numbers, you will get 20. The third type of media is the video. In the video, you have a file size of 6 and 2500 megabytes, and the download time is 125 seconds. So the ratio is 125 to 6 and 2500. And if you divide those two numbers, you also get 20. We say that the ratios for each pair of data are equal or equivalent. So the download time and the file size are proportional. The Convince Me asks, how can you show that two quantities have a proportional relationship? Well, all you have to do is prove that the ratios are equal. Then you have a proportional relationship. Example 2. Decide whether quantities are proportional. Is the relationship between the area and the side length of the squares proportional? Explain your reasoning. Step 1. Make a table to organize the data. Find the ratio of area to side length for each data pair. Well, the one thing that we need to know is how to find the area of a square. So remember, area is length times width. And on a square, the length and the width are equivalent numbers. So the area is this space inside a 2 by 2 square, or 4. Remember, the area is 2 times 2. In a 3-inch square, we have a 3 by 3, which is 9. And in a 4-inch square, we have 4 by 4, which is 16. So these areas are found by multiplying the sides of that square together. Now, as we compare the area to the side length, those ratios, we have a ratio of 4 to 2, 9 to 3, and 16 to 4. But take a look at the equivalent ratios that they create. 2 to 1, 3 to 1, and 4 to 1. And these ratios are not equivalent. Therefore, we do not have a proportional relationship between the area and the side length of those squares. Now let's look at the try it question that goes with example 2. The table at the right shows information about regular hexagons. Is the relationship between the perimeter and the side length of the hexagons proportional? Explain. Well, the first thing that we need to know is, what is a hexagon? Okay, a hexagon has 6 sides. So you might recognize a regular hexagon looking like this. All 6 sides of that figure are equivalent, and to find the perimeter, you have to add those sides together. Well, since all of them are equivalent, then the perimeter is simply 6 times the side length. So 6 times 2 and 6 times 3. That's how we get the perimeter for those hexagons. In order to prove whether this is a proportional relationship, we have to look at the perimeter compared to the side length. And those ratios are 12 to 2 and 18 to 3. So let's find the unit rate for each of those, or simplify to find an equivalent ratio for 12 to 2. And if I divide both parts by 2 in the first ratio, I get a ratio of 6 to 1. If I take the second ratio and I divide to make it a unit rate, which means dividing by 3, I also get a ratio of 6 to 1. Therefore, this is a proportional relationship. Example 3. Use proportions to solve problems. A proportion is an equation that represents equal ratios. Use the table at the right. How many times will a hummingbird beat its wings in 60 seconds? Step 1. Verify that the quantities are proportional. So here are the ratios from the table, and each of them simplifies to the same unit rate. So we do have a proportional relationship. The second step is to write and solve a proportion. In this case, we know that the proportion is whatever the number of wing beats is, we are going to divide that by the number of seconds. And since there are 60 seconds in 1 minute, we use the number 60. It is equivalent to the unit rate 80 to 1. So we are going to use our knowledge of solving an equation, okay, a division equation in this case because y is the number we are looking for, and we are going to multiply both sides by 60 to solve for y. So remember, if I have multiplying and dividing by the same number, those cancel each other out. So when I multiply 80 over 1 times 60, which is the same as 60 over 1, I get 4,800. That's one way to solve a proportion for a missing value. In this case, the hummingbird will beat its wings 4,800 times in 60 seconds. To check yourself, you can use that answer, 4,800, in 60 seconds and come up with the equivalent ratio, which is 80 to 1. And you would do that by dividing both parts of your ratio by 60. So this checks out and tells us that we have a correct answer. We are going to bypass the try it question for example 3. So you can put an X through that, and we are going to move on to the next page. For our practice work, we're going to first look at the key concept, and then we're going to have you complete numbers 4 through 10, 12, 13, and 15 on pages 100, 101, and 102. Let's first take a look at the key concept. The key concept reminds us that two quantities, x and y, have a proportional relationship if all the ratios for the related pairs of x and y are equivalent. Okay, remember, here's the x number, here's the y number, and we are going to compare them with the y number at the top of the ratio and the x number at the bottom of the ratio. We also are told that a proportion is what happens when we have two ratios that are equivalent. So we can use an equation to write that relationship. Let's try question number 4 together. Use the table below. Do x and y have a proportional relationship? Explain. So the way that we can show that is by using equivalent ratios for y to x and see if they are equal to each other. So the first ratio is the ratio 5 to 2. Remember, we're going to do the ratios in the form of y. Oops, let me try that again. Y over x. So 5 to 2, we have the ratio 7 and 5/10 to 3. So we're going to want calculators handy. We have the ratio 12 and 5/10 to 5. And we have the ratio 18 to 8. So let's change each of these into a unit rate, meaning What is it compared to 1? So use your calculator to find that unit rate for each of these ratios. I'm going to pause this and then we'll come back and check this together. Take a look at the equivalent ratios when you find the unit rates. 5 to 2 becomes 2 and 5/10 to 1. 7 and 5/10 to 3 becomes 2 and 5/10 to 1. 12 and 5/10 divided by 5 becomes 2 and 5/10 to 1. But 18 divided by 8 is 2 and 25/100ths to 1. So when you look at the unit rates for each of these, you have one unit rate that is not the same. So the relationship in the table is not proportional. In order for this to be a proportional relationship, all of those ratios from the table must be equivalent. And in this case, when one ratio is not equal to the other 3, that makes the entire table not proportional. Question number 5. Each triangle is equilateral. That means all the sides are the same. Is the relationship between the perimeter and the side lengths of the equilateral triangles proportional? Explain. So we have to look again at the relationship between the perimeter and the side length. So that's how our ratios are going to be written. The perimeter, remember, is the distance around the figure. So a 1-inch triangle has a perimeter of 3. A 2-inch triangle has a perimeter of 6, 2, 4, 6. And a 3-inch triangle has a perimeter of 9. So let's take a look at these ratios. The first triangle has a ratio of 3 to 1. The second triangle has a ratio of 6 to 2, and the third triangle has a ratio of 9 to 3. So the ratio of 3 to 1 is already in its unit rate format. But let's do the same thing with the other 2 triangles. The ratio of 6 to 2, we can divide each of those parts by 2. And 6 divided by 2 is 3. So I get another ratio of 3 to 1. In the third triangle, I can also make a unit rate, this time dividing both parts of that ratio by 3, and I get a ratio of 3 to 1 again. So since all of these ratios are equivalent, this is a proportional relationship. This is a proportion. Question number 6. Is the relationship between the number of tickets sold and the number of hours proportional? If so, how many tickets were sold in 8 hours? So it's asking us about the relationship between the number of tickets and the hours. So that's the ratio that we are going to create. There are 3 of them here. 240 to 3, 400 tickets to 5 hours, and 720 tickets to 9 hours. So the first thing that I would like for you to do is create those unit rates. Find out if these unit rates are the same for the number of tickets sold in 1 hour. Pause the video while you calculate and then come back and check your answers. And what I hope you found is that 80 tickets were sold in 1 hour for all 3 of those relationships in the table. So we do have a proportional relationship. The next question asks us, if so yes, this is proportional, how many tickets were sold in 8 hours? Well, we have 80 tickets in 1 hour. So how many tickets would that be in 8 hours? So we're looking for that Y number. In this case, I would need to multiply both parts of my equation times 8 to get Y, the number of tickets, is 8 times 80, which is 640 tickets.